let's go to page 639. Start with number 1. Okay, you want to simplify, so you got sine alpha, secant alpha. Okay, so when you simplify something, okay, if you're not sure what to do, just convert it into sine and cosine. Okay, and so secant is 1 over cosine. Okay, and so now you have sine over cosine. This will equal to tangent alpha. Okay, okay, number 3. You have tangent x over sine x. Okay, so tangent is equal to sine over cosine, and sine will be just sine over 1. Okay, now you have complex fraction. You can do the outside over the inside, or just multiply by common denominator. Okay, so you go outside, so this will give you sine x over the inside, so it will be sine x cosine x. Okay, and then the sine x will cancel out, so 1 over cosine equal to secant. Okay, number 5. Yeah, 1 minus sine theta times 1 plus sine theta. Okay, so this is conjugate. So go and multiply the conjugate. So 1 times 1 is 1. Now conjugate, the O and I will cancel out, so you just go and use the F and L. So this with 1, plus times minus would be minus. Sine squared times, sine times sine would be sine squared theta. And 1 minus sine squared theta will equal to cosine squared theta. Okay, and that's it. Okay, let's go to next one. Okay, number 7. Okay, yeah, cosine of alpha, cosecant of alpha, tangent of alpha. So again, when problems get complicated, just make everything to sine and cosine. So this is equal to cosine alpha. Okay, cosecant is 1 over sine. Okay, tangent is sine over cosine. Okay, and so now if you notice, this will cancel out, and this will cancel out, so answer will equal to 1. Okay, number 9. Yeah, sine x over cosecant x plus cosine x over secant x. Okay, so again, first let's go and convert everything to sine and cosine. So this is equal to sine x over, so cosecant is 1 over sine x, and secant is 1 over cosine x. Okay, so next is when you have complex fraction, what you want to do is multiply. You can use outside over inside, or you can just multiply by the common denominator. So you can multiply by sine x, so that this will cancel out. So this becomes sine square x. Okay? And for this one, again, denominator is cosine, so you want to multiply by cosine x. So this will cancel out. So this becomes cosine square x. So sine square plus cosine square, this is equal to 1. Okay. Okay, number 11. So you got secant theta over cosine theta minus 1. Okay, so let's go ahead and make everything to sine and cosine. So this will be cosine theta. Now secant is 1 over cosine and minus 1. Okay, and again, when you have complex fraction, to get rid of a complex fraction, let's go and multiply by cosine theta, both the top and the bottom. So this will cancel out. So you got 1 over cosine squared theta minus. Okay. Now since we're going to subtract fraction, we need to get common denominator. So 1, notice it's cosine squared, so I'm going to make into cosine squared theta over cosine squared theta. So I get common denominator, right? Again, 1 is cosine squared over cosine squared. Okay, so now we can go and combine this together. So on the top, I get 1 minus cosine squared theta over cosine squared theta. Okay, but 1 minus cosine squared is equal to sine squared theta. Okay, and sine over cosine is tangent, and because it's square, so it would be tangent square theta. Okay. Okay, let's go to the next one. Okay, number 13. Yeah, 1 plus tangent square alpha over tangent square alpha. Okay, so again, if you're not sure about the identity, then what you do is just go ahead and make everything to sine and cosine when you're simplifying. So make everything, so tangent is equal to sine over cosine, and I make the 1 as 1 over 1. Okay, and tangent is sine square alpha over cosine square alpha. Okay, so again, if you're not sure what to do, just make everything into sine and cosine. Okay, now when you have complex fraction, to simplify complex fraction, multiply by everything by the common denominator, so multiply by cosine square theta, cosine square alpha. Okay, so this one had nothing to cancel, so this would be just cosine square alpha. This one, the cosine square cancel out, so you get sine square alpha. And this cancels out, so you get sine square alpha. But sine square plus cosine square equal to 1. Okay, so sine square plus cosine square equal to 1. And then 1 over sine equal to cosecant, and so square you get cosecant square alpha. Okay. Okay, number 15. Okay, you got cosine square 50 degrees plus sine square 50 degrees. Now, if they're the same, right? So sine square plus cosine square equal to 1. So if they're the same degree, then you just use identity, right? Okay, so this is equal to 1. Okay, 17. Cosecant square t minus cotangent square t. Okay, so again, if you're not sure what to do, make everything into sine and cosine. So cosecant is 1 over sine. Cotangent equal to cosine over sine. Okay. And now you have common denominator, so you can go and combine them together. But 1 minus cosine square will give you sine square. Okay. Now you have sine square over sine square, this will equal to 1. Okay, number 19. Yeah, sine alpha cosine alpha over 1 minus sine square alpha. Okay, well, let's go ahead and simplify this part over here. 1 minus sine square equal to cosine square. Okay. And the cosine and cosine square will cancel out, so you end up with a cosine alpha. And then you have sine over cosine, this will equal to tangent alpha. Okay. Okay, number 21. Okay, secant x minus sine x tangent x. Okay, so secant is 1 over cosine of x. And you got sine x. Okay, tangent is sine over cosine. Okay. And so now you're going to end up with, so you have common denominators. You're going to get 1 minus sine square x over cosine x, right? It's your common denominator, so 1 minus sine square. Well, but 1 minus sine square will equal to cosine square. Okay, and you go cosine square over cosine equal to cosine x. Okay, let's go to the next one. Here you got 1 minus sine square phi over 1 minus sine phi. Okay. Let's see how we're going to do this. Oh, that's minus 1. Okay, that's why I say it looks kind of strange. Okay. Well, for this one actually, if you factor this, you can cancel out with that. Okay, so 1 minus sine square will give you 1 plus sine 1 minus sine. Let's see if this will work. Okay, and minus 1. And this will cancel out. Oh, okay, so it works out. So 1 plus sine phi minus 1. So 1 and minus 1 will cancel out. So it's just equal to sine of phi. Okay. So you just have to factor into conjugates, and this will cancel out. And then once you cancel out, you got 1 plus sine minus 1. So 1 and minus 1 will cancel out. So it come out kind of nice. Okay. Okay, number 25. Secant of x. Okay, write the first function in terms of the second function. Okay. So what you need to do is you want to write this in terms of that. Okay. Then what you need to do is draw the picture on this. Okay. So sine of x is like x over 1. So that means this is x and this is 1. Right? Sine is opposite over hypotenuse. So sine x over 1 means it's x over here and this is 1 over here. So that means this over here, if you use Pythagorean theorem, this will equal to plus or minus. Okay, you know, again, you're going to have, let's go and call this a. Okay, so you're going to get a squared plus x squared equal to 1. So a squared equal to 1 minus x squared. Take the square root, so a can be equal to plus or minus square root of 1 minus x squared. Okay. And so secant is 1 over cosine. So secant of x equal to 1 over cosine x, right? So cosine is equal to this over that. So it'd be this over that. Okay, and when you flip it over, so again, cosine is this over this, right? And secant is this over that. So this will equal to 1 over plus or minus square root of 1 minus x squared. Okay. And what's x squared? Well, notice the okay, let's do this. You have to use identity. So this is one answer, but this is not the answer they want in the book. Okay, so let's do this. So you're looking for secant of x in terms of that. Okay, so secant of x equal to 1 over cosine x, right? And if you use identity, cosine square x plus sine square x equal to 1. Okay, so cosine square x equal to 1 minus sine square x. And take the square root. So cosine x equal to plus or minus square root of 1 minus sine square x. And you substitute. So secant x equal to 1 over plus or minus square root of 1 minus sine square x. Okay, and that's it. Okay, so you can use the identity over here. Okay, so you have tangent t, and you're looking everything in terms of sine t. Okay, so you can first tangent equal to sine t over cosine t, right? And again, from last time, we know that from here cosine equal to that, right? So just substitute. So you're going to get equal to sine t over plus or minus square root of 1 minus sine square t. Okay, and that's it, right? So again, once we derive what cosine equal to, we can just use that over and over and over, okay? Okay, number 29. Yeah, tangent alpha, secant alpha. Again, you want to put everything in terms of sine alpha. Okay, so again, so tangent equal to sine over cosine. Secant is 1 over cosine. Okay, and so this is equal to sine alpha over cosine square alpha. Okay, now if you go back to over here, see over here cosine square equal to 1 minus sine square, right? So we can use this one over here to substitute into here. So this will equal to sine x over, okay, again cosine square equal to 1 minus sine square x. Okay, and that's it for number 29. Okay, number 31, you want to prove each identity. So you got sine square x times 1 plus cotangent square x equal to 1. So again, you want to simplify the side that's more complicated. Okay, so first, again, if you're not sure what to do, convert everything to sine and cosine. So cotangent is equal to cosine square. Cotangent square equal to cosine square over sine square. Then you go and distribute. So this times this will equal to sine square x. Okay, this times that. Notice the sine square cancel out, so it will be cosine square. It's plus. So it looks kind of strange. So it will be plus cosine square x equal to 1. Again, this is one of your identity. Sine square plus cosine square equal to 1. And so check. Okay. Okay, 33. You got cosine square minus sine square theta equal to 1 minus 2 sine square theta. Okay. So this one is let's go and simplify this part over here. Since you want to convert it into sine, so convert this into cosine square equal to 1 minus sine square, right? And again, when you simplify this, you're going to get 1 minus 2 sine square theta. And that's it. So check. Okay? So again, you have to get the two sides exactly equal to each other, and you put a check mark, means you prove it. Okay, let's go to the next one. You got cotangent phi plus tangent phi equal to cosecant phi secant phi. Okay. It doesn't matter. Let's go and do this side then. Cotangent equal to cosine over sine, and tangent equal to sine over cosine. Okay, and when we add, we're going to get into common denominator, so we need to get sine phi cosine phi. So from here to here, okay, let's do this. Okay, so from here to here, we're missing the cosine phi. So you have to multiply by, so you need to go and multiply by cosine of phi. So you're going to get cosine square phi. Okay, and this over here, from here to here, I'm missing the sine. So I need to multiply by sine phi. So I will get sine square phi. Now when I add this together, cosine plus sine square will equal to 1. So this becomes 1 over sine phi cosine phi. Okay. Now, so 1 over sine is cosecant. 1 over cosine is secant. Okay, and that's it, check. Okay, number 37. Got cosine to the 4th power x minus sine square sine to the 4th. Okay, this is equal to cosine square x minus sine square x. Okay, so let's go and factor this. This can factor into difference of square, right? This is a different square, so factor into conjugates. So you're going to get cosine square x plus sine square x, cosine square x minus sine square x, right? Again, you have difference of square, factor into conjugates. Okay, but sine square plus cosine square equal to 1. Okay, so this equal to 1. And 1 times whatever is just the same, right? So be just, so this is just cosine square x minus sine square x equal to cosine square x minus sine square x. Okay, and that's it, check.